All right, who's ready to learn about the subject we all know and love? Chemistry! Woohoo! Okay, so why is chemistry important? Well, you're asking a chemistry teacher, so I'm going to give you an answer. Everything you do is chemistry. Literally, even your body is made of chemicals. Okay, chemical reactions happen when you breathe, when you eat, or even if you just sit there and play video games. So we're going to start with the atom, okay? Atoms are the basic building blocks of life. I'm sure you've heard that many times before, but I'm going to tell you again. Atoms are the basic building blocks of matter, and they make up everything. A desk, the air, even you are made up of atoms. There are 90 naturally occurring atoms, and scientists in labs, who are very smart people, have been able to make about 25 more. And that's what you see on the periodic table. Before we get into the periodic table, we're going to start with atomic structure. So this right here is what an atom looks like. There are three main particles. There are protons, neutrons, and electrons. And as you can see in what this is called a Bohr's model, the inner portion, so the orange and the green, are the protons and the neutrons, and that makes up what is called the nucleus. And the outer portion, these rings around the nucleus, is called the electron shell. We can just call it a shell, and that is composed of electrons. So let's break this down. What is a proton? Like I said, the proton they are these orange little circles in the nucleus, okay? Remember, they're in the nucleus on the inner portion of the atom, and they have a positive charge. Protons are positive, so just think P. Protons are positive, okay? They have a positive charge. A neutron, so that is also in the nucleus, and they are the green little circles in that picture. They have no charge, or they are neutral. So protons are positive and neutrons are neutral, okay? And the neutrons are actually the largest type of particle. They add mass to the atom. So the neutrons are pretty much, they make up the weight of the atom. And the third particle is an electron, okay? So they make up the outside of the nucleus. They are in the shell. They have a negative charge, and they are very small. So electrons are the smallest, neutrons are the largest. And you can see that in this picture right here. So neutrons, which have no charge or are neutral, are very large. Protons are positive, and they are very similar in size. They're comparable to the neutron, but not as large. And then look how small an electron is with the negative charge compared to the proton and the neutron. It's pretty tiny, so it doesn't really add a ton of mass to the atom. Next, I'm going to introduce you to the periodic table of elements. We will go over this more in class, but I wanted to just dip our toes into the subject really quickly. So this is my favorite periodic table. Yes, I have it bookmarked on my laptop. Don't judge me. But I want to zoom in to this little corner right here, okay? So each element has this little square, has its own little square in the periodic table, and where that square is placed is very important. It tells us all we need to know about that particular element just by where it is placed in the periodic table. Okay? It tells us about the protons, neutrons, and electrons like we just talked about. So zooming into that little hydrogen square, I just chose hydrogen because it is number 1 on the periodic table. So the H, or if you look here, like lithium is Li, beryllium is Be, and so on and so forth. That is called the chemical symbol. So it's either going to be 1 or 2 letters right here. Those are the chemical symbols. So if you hear me refer to a chemical symbol, that is what I am referring to. And then there are 2 numbers that we are going to pay attention to in these little squares of the elements, okay? So this number that is in the top left corner of these boxes is called the atomic number, and that tells us the number of protons. Okay? And if you notice in the periodic table, the elements are lined up by atomic number, increasing atomic number. So hydrogen is 1. If you're reading like a book left to right, hydrogen is 1. All the way over here, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, and so on and so on. Okay, I'm not going to read you the whole periodic table because that would be boring to both you and me. Okay, so the atomic number tells us the number of protons. So hydrogen has 1 proton, helium has 2 protons, and so on and so forth. The next number that I want to look at is in the bottom left corner of the square, and this is the atomic mass. So this number equals the number of protons plus the number of neutrons. Okay? So atomic mass is the number of protons plus the number of neutrons, and the atomic number is just the number of protons. So out of these two numbers, you can tell me the number of protons by just looking at the atomic number, and you can tell me the neutrons by taking the difference between the two. Okay, so if you take the difference between the atomic mass and the atomic number, you get neutrons. Okay? So now what about electrons? I'm sure you were thinking the same thing. So if atomic number equals protons, atomic mass is protons plus neutrons, what about electrons? Well, in a regular, and the word we are going to use for regular in chemistry is neutral. So in a neutral atom, the number of electrons equals the number of protons. And how does that make sense? So electrons, remember, are negative and protons are positive. So if negative equals positive, then that means that they cancel each other out, so our charge is 0. We don't need to worry about charges at this exact moment in time, okay? But I just wanted to explain that that is why electrons equals protons in a neutral atom. All right? So I've been talking for about 7.5 minutes, and I'm sure you are tired. So this is to be continued, okay? This is just dipping our toes into the world of chemistry. All right?